Hi guys! Another video by me. I couldn't find a good one online, so I hope this one's okay. So today, or Friday, in class, we started talking about arithmetic series. And if you remember, a series in general is just the sum of the terms in a sequence. So there again is the definition for a series. An arithmetic series would just be the sum of the terms in an arithmetic sequence. We also used our critical thinking skills to come up with a formula for finding the sum of an arithmetic series. And so again, that formula is here. And in this formula, this part here is standing for the sum of n terms, and you'll fill in some number for that. For example, if I wanted the sum of the first 10 terms, that's 10, that would be the notation for it. And if I wanted the sum of the first 10 terms of some arithmetic sequence, then 10 would be n. I would also have to know my first term and my last term. So my first term, we know that sequence, or that notation, sorry, and my last term. So let's just do an example to refresh our memories on that. Okay, so here's our first example. Find the sum of the first 20 terms in the following sequence. And my sequence is 3, 7, 11, 15, 19, and so on. Okay, so first we have to determine that this is arithmetic, which it is because I'm increasing by 4 each time. So it's arithmetic, and my common difference is 4. Since it's arithmetic, I can use my new arithmetic sum formula, where I take the number of terms times the first term and the last term, all divided by 2. Okay. Now, if I wanted to do the series for this sequence here, I would have to put in plus signs in between them. So I gave you a sequence, but the series would be this. We're now going to add up the first 20 terms. So let's see what we can fill into our equation right now. Since I want the sum of the first 20 terms, my n is going to be 20. So I would write down the sum of the first 20 terms, there's my notation, equals 20 times. I can also fill in my first term because I have that right up here, it's 3. But I can't fill in the last term. In this case, since I want the sum of the first 20 terms, the last term would be the 20th term. I don't have that yet. So we're going to have to go over to the side here and figure out the 20th term. Well, since this is again an arithmetic sequence, or series, I have a formula for finding terms in arithmetic sequence. We just had a quiz on it. So that formula was T1 plus n minus 1 all times d. So I'm going to fill in what I know. I do know the first term, it's 3. I do also know n, it's 20, and I know d. D is 4. So I could do out this math here, and I would get my 20th term. So that term there is 79. Now that I have my 20th term, I can fill that in right here for my last term. So this is now 79, and then in the formula I'm supposed to divide this all by 2, because if you remember from class, we're making pairs of the first and the last term and the second to last term. So I would have, in this case, 10 pairs. 10 pairs of 82. Okay, so if I simplify this, this is 10 times 82, which is 820. So the sum of the first 20 terms of this sequence that I gave at the top is 820. Let's do one more example just to see, sometimes we're given different information. Okay, and I'm sure it's understood that you should be taking notes on the different examples that I put in this video. So in class next week, I will check that you have the notes and these examples done out. Of course, if you have any questions, you could write them down in the margin. You can always pause the video, rewind it to hear it a second time if you're not sure of something. So let's look at a second example. So example 2 says, find the sum of the finite arithmetic series 3 plus 13 plus 23 plus, then you'll notice I'm missing some terms in the middle, and my last term is 93. All finite means is that it ends. Remember, infinite means it never ends. Finite means there's an end, and we are ending here at 93. So let's set up our formula and see what pieces we can put in. So here's our arithmetic series formula. Again, this will only work if you're dealing with an arithmetic series, which we are. If I had some other series like geometric, I could never use this formula. Okay, we'll get to that another day. So, as soon as we start, we run into a problem. I'm supposed to find the sum of how many terms? I don't actually know that because I have this dot, dot, dot in the middle. So I don't know how many terms there are, which means I can't fill in n. So we're going to have to go find n. I can fill in my first term. My first term is 3. And my last term this time. In the previous example, we had to go find the last term. My last term is 93, so I can actually fill that in right away. And of course, I can always divide by 2. I need to now go find what n is. So to do that, since I want to find how many terms are there, I better go use my term formula for an arithmetic sequence, which is, again, this same formula that we had to use in the last example, only this time I don't know n. In the previous example, I did know n. I do know my last term though. So we've done these before where we had to figure out how many terms are in the sequence. So let's fill in what we know. I do know the nth term is 93. I do know my first term is 3. I don't know n, that's what we're going to solve for, but I do know d. I haven't actually listed that yet, but if we go back up to our sequence here, I'm increasing by 10 each time, so my d is 10. So down here in my formula, I'm going to fill in 10. Now I would have to solve this out to find n. So I'm going to subtract 3 from both sides to get 90 equals n minus 1 times 10. I'm going to then divide both sides by 10 so that I get 9 equals n minus 1. And so now I know n is 10, which means there are 10 terms. So I'm going to go back to my formula, and I now know that n is 10, which means I'm really finding the sum of the first 10 terms. So if I do that out, 93 plus 3 is 96. And I'm going to end up doing 10 divided by 2 here. So I'm really doing 5 times 96. And 5 times 96 is 480. So now I know the sum of the first 10 terms is 480. So just to review, in this problem, I had to go and find n, the number of terms. And to do that, I had to go back to my term formula. So in both examples, if you remember, we had to use this term formula. So even though we're now adding up terms and we need this series formula, we still need our old formula for finding terms. The last thing I want to discuss on this video is a shorthand notation for writing series or sums. It's called sigma notation or summation notation. So sigma notation or summation notation. Your book is referring to it as sigma notation, which is a very common way to call it because it involves the Greek letter sigma. So this is the symbol sigma. When you see this symbol, it's understood that you're dealing with a sum. So when you see something like this, you'll know you're adding up terms. So let's look at the previous example where we had 3 plus 13 plus 23 plus ... plus 93. And we determined in that sequence that there were 10 terms, so n was 10. We also know that the difference is 10. It's just a coincidence that these two numbers are both 10. Okay, they're not always the same, as we've seen before. So since there are 10 terms that I'm adding up, in our notation down here, you always list at the bottom the number that you're going to put in for n first. Well, we're going to usually use 1 for n for our first term. And up at the top, you put the last value for n that you're going to put in. Our last value for n, since there are 10 terms, is 10. So from here to here, this tells us how many terms we're dealing with. From 1 to 10 is 10 terms. Okay. Now, the only other thing we have to fill in is the explicit formula for this sequence. And that's going to go right here. So for our explicit formula for the sequence, that's my term formula. Since it's arithmetic, I'll be using this again. I think I did this on the previous slide, so if you already have it, you don't need to write it again. But our term formula, I would fill in my first term, I would leave n as n, and I would fill in my d as 10. And then I would simplify this, so I would distribute my 10 to both terms here, and I'd get 3 plus 10n minus 10. So my formula for t sub n is 10n minus 7. So that's the formula, this part right here, that's going to go right up here. So on to the right of your sigma symbol, you're going to put 10n minus 7. Now, this notation that I have here, this entire thing is saying, in a shorthand notation, the sum of the first 10 terms of the sequence generated by this formula. So if I were to now evaluate this, I would start with this number down here, 1, and I would put that in first. So my first number would be 10 times 1 minus 7, which is 3. Okay, which we know from up here. Okay, so that's my first number that I would be adding. So this would equal 3 plus, then to get my second number, I would put in 2 for n. We've done this a lot. And that would give me 20 minus 7, which is 13. So that would be 13, which again, we have right here. It should be generating the same sequence, and so on and so forth. So I would be adding 3 plus 13 plus 23 plus 33 plus 43 plus 53, all the way up to my last number for n, which is 10, which would give me 93. Okay, so this notation, sigma notation or summation notation, is just a shorthand version for writing out this series. That's all that I have for this video, and now you'll have to do a few problems in the book that demonstrate you understand what was in this video. Thanks a lot. See you soon. Bye.